This recording is about using the Casio fx991es calculator in matrix mode. This calculator has advantages over the 85 which students often come to college and university with. On the 85, if you look under the mode button, you will see you have 4 modes on the 85, whereas on the Casio 991es under the mode button you have 8 modes. These modes are particularly useful for undergraduate use. So to select the matrix mode of operation for the calculator, we choose mode 6. Initially we're presented with a screen and we're going to cancel that. I'm going to try and outline to you how you can use the calculator. So thinking about entering matrices in the calculator, now we're in matrix mode. To enter a matrix we press shift and then the matrix menu under 4. We choose 1 to dimension the matrix, choose its size. And we're going to choose out of 3 matrices, we're going to choose matrix A, which is 1. The size of the matrix will be a 2 by 2, 2 row, 2 column. So this is 5. I'm now looking at a matrix where I can enter the numbers into placeholders. So for instance, the matrix on the left here, 1, 2, 3, 4, 1 equals 2 equals 3 equals 4 equals. I've now entered the matrix. I can clear the display, and whilst I'm in matrix mode the calculator will remember the matrix A as being 1, 2, 3, 4. I can reselect the matrix under the menu again, shift matrix, and selecting matrix A is 3, and if now press equals I can see the matrix that I previously entered. If I want to multiply that matrix by 2, I would say shift matrix, matrix A is 3, and then times 2 and press equals. So multiplying by a scalar in this case doubles the size of the matrix 2, 4, 6, 8. I can add and subtract matrices, so if I enter another matrix now, 5, 6, 7, 8, shift matrix, this is going to be matrix B, which is 4. Apologies, try that again. Shift matrix, I should say dimension first, and then matrix B is 2. It's going to be a 2 by 2, which is 5. I'm putting the numbers now, 5 equals 6 equals 7 equals and 8 equals. Now I've entered the numbers there. You'll notice that this number is highlighted and it appears bigger. So if I want to highlight something, one of the elements of the matrix, I just highlight it and it appears bigger. This may be an advantage if we're looking at decimals or fractions. So having specified a second matrix, matrix B, I'm now going to add them. Shift matrix, I choose 3, matrix A, plus shift matrix, matrix B is 4, and press equals. And that's giving me the sum of the 2 matrices. I can also subtract in the same way, shift matrix 3 minus shift matrix 4, matrix B, and I get negative values from subtraction. Okay, multiplying matrices together then, other than scalar multiplication, shift matrix 3 for matrix A times shift matrix and 4 for matrix B gives me 15, 22, 43 and 50. That's the result of multiplying a 2 by 2 and a 2 by 2 matrix. If you attempt to multiply matrices that cannot be multiplied, it will give you an error message. Okay, looking at the screen then, I can also do the determinant of a square matrix. So we need to select from the menu, shift matrix. The determinant is 7, det, and if I choose the first matrix, matrix A 1 2 3 4, shift matrix, matrix A is 3, det, close the bracket, equals, and I get -2, which is the determinant for that matrix. Next operation I want to highlight is transpose. Transpose is where the rows and columns are transposed. The command for this in the matrix menu is trn, which is 8. So I'm going to transpose matrix A 1 2 3 4. That's 3 for matrix A, close bracket, equals, and that's what I expect. 1 3 2 4. Okay, the next operation to illustrate, this is finding the inverse of a matrix. So the inverse is achieved by selecting the matrix 3 and using the reciprocal key x to the -1 and press equals. This is now the inverse of the matrix. I'm seeing -2, 1, 1.5 and -0.5, and notice when I highlight 1.5 it expresses this as a fraction, and that is 3/2. So when you are expressing the inverse of a matrix, you'll get decimals in the matrix, but you can detect them as fractions by highlighting them. If that was the correct inverse, multiplying the original matrix by its inverse should then produce the unit matrix 1001, and we can check that out. Shift matrix 3 times shift matrix 3 again, choose inverse, and this should produce the unit matrix, and it does, 1001. The next operation I want to show you is for 3x3 matrices. So this time I'm going to dimension the matrix. So apologies, try that again. Shift matrix, and we're going to dimension matrix. This time we're going to use 3 for matrix C. This one's going to be a 3x3, which is 1. And now I can fill in the elements: 1, 4, 5, 7, 2, 6, 3, 1, 3. Once I press the last equals, whilst in matrix mode, the calculator will remember that matrix. So if I wanted to find the inverse of that matrix, shift matrix, matrix C is 5, I want the inverse, press equals, and I get a matrix containing a set of 9 decimals. If I were to select one of the decimals by going down, the 0.4285 is expressed as 3/7. And if I'm using this matrix, if I was doing this manually to find the inverse matrix, I would have done that by finding the adjoint and then dividing it by the determinant. Well, the determinant for this matrix is -7, and this is the adjoint matrix. So multiplying those two things together gives me this matrix now with 9 elements, which is the inverse. And if I compare it to what I'm seeing over here, I can see I've got the same fractions. That's 12/7, -29/7, down here 26/7, -11/7, and -1/7. So the calculator has correctly produced the inverse, and again I can check. Shift matrix, matrix C is 5, multiply that by its inverse, shift matrix C is 5 again, inverse, and this now produces the unit matrix for a 3x3 expressed as 1 0 0 0 1 0 0 0 1. And so that concludes the demonstration for using the Casio FX991 calculator in matrix mode. You may be able to buy this calculator if you look on the internet. So for instance on Amazon, I'm seeing this at $17.67 at the end of January 2017. You can get it from eBay and other places, possibly slightly cheaper. Thank you.